Good morning, everyone. I hope you're all doing well. So welcome to our session of Data Science Seminar, where we're discussing Advanced R. Today we will be discussing Chapter 15, which is about S4 objects, which I'm really interested to learn more about. So if you use Bioconductor, S4 objects are very common and a fundamental part of Bioconductor. And who better to present on it than Marcel? So with that, Marcel, would you like to get started?
Yeah, thanks. I'll share my screen. Should be able to see that. So today we'll talk about a system that I've been using for a while now, S4. And there are three essential functions that will allow you to create objects for the S4 system. These are set class, set generic, and set method. And for our outline here, we'll get a quick overview of the components of S4, those classes, generics, and methods. And then we'll look at some prototypes, constructors, helpers, and validators. And we'll learn how to create new S4 generics and supply those generics with methods. I will also chime in on when to create a generic and the scenarios that's appropriate for. And we'll dive into some details of S4 dispatch, which can get pretty complicated, especially with multiple dispatch. So S4 in general is a more structured approach to working with classes. We learned about S3, where you can simply just add the name of your class to with the class function, and there are not a lot of validation steps that happen when you do that, and there are ways to change values. So S4 is a little bit more strict in when it comes to creating classes, and there is no one reference that will answer all of your questions about S4. And the bioconductor community has long used S4 since I guess the very beginning, where we started, or Hervé and other contributors started working on the bio-based class and genomic ranges. So those are a couple of good resources. Just Martin Morgan and Hervé Paget is his name. And they often comment on ways to implement S4 classes and methods, and you can look at our contributions.bioconductor.org for some advice. Also, Martin Morgan has a lot of questions answered on Stack Overflow, so that's a good resource too. And also John Chambers, who authored the S4 system and has a book about functional programming. Those are good resources for learning more about S4. We'll cover mainly just the basics, but as always, it can always get more complicated. So let's start with the prerequisite. So the methods, S4 is essentially implemented in the methods package, and it comes installed in R. So if you, just to double check, you should load the methods package and do library methods. So we'll start with the set class function, and this is what provides a generator function, and it tells R that you're creating an S4 type of class, and first argument is the name of the class, and the convention is to have a capital case name of the class. So this is capital P person, and you will tell R that you have some slots in this class, and those are value stores in the class. So you will have a name slot and an age slot, and you can specify what type of data you want in that slot. So character for the name, numeric for the age. So it's a good setup, right? We tell R exactly what the requirements are, and so we have a little bit more structure when it comes to creating a person um, instance of that class. So you could use the new function to generate an instance of the class, but generally in Bioconductor, you take the output of the set class and use that as the generator rather than calling new. But you can do that as well, and that should work. One of the reasons we use the generator is because, as we'll see further down in the chapter, we will need to have a constructor function that validates our inputs. But for now, let's learn about what the new function does. So the new function requires the name of the class. So this class should be available. So if you haven't set the class, then it will give you an error because it will look for the class definition. And if it doesn't find it, then so you need to have the class definition first before you call new. And then you can provide your values. So in this case, John Smith, age, and a real. So it is also new. So it conforms to the requirements here that it's numeric, but it can also be NA numeric. And that will create an instance of the person class. And if you do is John, it will give you the name of the class or the membership of the class. And there are these accessor functions. So this is the @ symbol. If you do the object at the slot name, it will give you the value of the slot. So generally, you don't want to use this type of way to access your values. The person who's developing the class should have a way to access the values. So essentially, the developer should add a layer of protection, so to speak, for the user to not have to access directly those slots, because the developer, that gives the developer more freedom to change some of the internal components of the class. So maybe you come back to it and you say name is not a good value. Maybe you wanted to add first name. So you can change that as a developer, and the user can still use the outer layer, the API, which we'll go over and look at some of the accessor functions in the chapter. So it's possible, but not recommended. So and Hadley says you should only use @ in your methods, right? So it allows you to pull the value from the slot of that class. And then, so that's the instance of the class. Now we'll look at what kind of things we can do with the class. So it's good that we have a class, but we need to have some methods and some ways to work with the values in the class. So here we're creating a setter and a getter, or I also, this getter, I also call them accessor functions. So age here is an accessor function, but first you have to create a generic that will tell R that look for the method for this class. So first, the generic is just it can apply to multiple classes, right? It's just the standard function that will look for methods for a particular class. And so we're creating two generics here, the age getter and the age setter. So you see that there's this arrow in that setter. That means that we'll use it in a manner like this down here. So this is that setter notation. So once you create the generics, you also want to create a method that is particular to your class, and that is the person class. So you set method age, and then name of the class and how to pull out the value for that age. So this is that top layer that I was talking about for the end user. So it protects the end user from doing X at age, because you as a developer may want to change the name of the slot at some point, or add things to it, or add some computation in the bottom layer. So it gives you more flexibility for that. And then for the setter, usually have an X and a value input. So when we're setting something, we need a value to replace it with, right? So that's what the value here stands for. And the implementation is within the curly brace. That's the function. So you can assign directly to the slot that value, and then return X. So that is our setter method for our person class. And then once you have those, you can start to use them. So previously we had NA in the John instance of the person class. So now we can set his age to 50, and you can access the age value or the age slot by using the accessor function age. You get 50. So to look at the S4 class in a package, you can do class question mark person, and that will should give you the documentation for the person class. To get help for a method, put the question mark in front of the call. So you do age question mark age John, and it will figure out the help file that you need. So you can use Hadley's loop package to sort of get a nice reading of what objects we're working with. Here we use O-type on the John instance of the person class, and you'll see that it's an S4 class. F-type age. So F, I think, is function type. O-type is object type. F-type is this age function refers to the generic by default. So if you go to your console, if you set the generic and set a method age, and you go to your console and type age, you should see the generic first, because that's always the front line. And that generic will then go out and find the relevant method for the class that you have. So if we do age here, then it'll say this is an S4 generic. I'll skip the exercises for now, and hopefully we'll have some time to go over them towards the end. But now let's move on to how to define a class more broadly. So you define an S4 class with set class, and it has 3 arguments. You give it the name. So by convention, you have the upper camel case. So that's so capital P person in our example. And then you have a slots argument, which allows you to name your slot, but also not only name it, but also provide the data type for that slot. So in that example, we had character and numeric for name and age, respectively. And then there is a pseudo class called any that allows you to put objects of any type in a slot. So usually it's better to have a type. So I don't really use any in the slots argument, but you can. And we'll see how any pseudo class comes into play with other with methods dispatch. So, and then there's this prototype argument, which allows you to give it exactly that, I guess, a prototype or a template representation of your class. So it's a list of each of your slots, and it's optional, but Hadley recommends that you should always provide it. So we'll see how we could add a prototype here to our person class definition. Right, so we have the slots argument. The first argument was our name, so that's person, slots, and then the prototype, which is a list, the name, so you can provide a NA character. As long as it's a character type, it can be anything. You can have an empty string there. You can add like the double quotes for an empty string. And then for age, it has to be numeric. So in this case, it's NA real. So that's the prototype. And then as you can see, you can use new on the name of the class and provide a value for name, and that will give you a new instance of the person class. And if you do str on the me object here, you'll see that age is NA by default. So it gives you a way to provide default values if I'm reading that correctly. I don't use the prototype that often, but it's a good way to set up your default values. And now we'll talk about inheritance, which is one important argument to the set class, which allows you to tell R that my class is a descendant of another class. And that's, I guess, allows you to inherit behavior from the previous class. So let's say we have an employee class that inherits from the person class. So we're adding some more hierarchy to these classes, right? And then you can add an extra slot for to the employee class that describes their boss. So the boss is another person class instance. So you can see how the inheritance is working here with this contains argument. So the employee class has a person class instance, but it also adds a boss slot to the representation. So now you can add a prototype of the boss, which is just the instance of the person class. So you can call new person, and that should be the prototype of the boss slot. So you can see that not only do you get when you create a new instance of the employee class, you get the inherited slots from the person class. So you get name and age, but also the one that you added, which was the boss slot, which itself is also a person class. So it has its own name and age. So there are other 9 arguments in set class that are not used and not recommended. So those are the major ones to be aware of and use. And then we'll talk about introspection, so learning about the objects that we're working with. And we saw that is can tell you what class that object that you're providing is. So if you make a call to new person, you're creating a person class instance, is will tell you this is a person class instance. Same thing with employee, but it will also tell you what class it contains. So that is the person class. It's not only an employee class, but also has a inherited person class. And then to check for class membership, it's good to use the second argument of is, and that is the thing that the class that you want to check for. So is the John object a member of the person S4 class? And that will say true if it inherits from person or is a person class instance. And that's good for your tests within your functions or in your constructor. So then we'll talk about modifying your class definition. So you can call, say we have a class A that has a slot X that is numeric. You can create an instance of that A class and assign it to this lowercase a object with a value. But if you redefine your A class with a new slot and add a different slot to it that is type numeric, you should not. So here it gives you an error. There's no slot of name, a different slot for this type of object. So when you redefine it, I think R is checking that A has that slot and it doesn't have it because it was created when it didn't have that slot up here. So it gives you an error. So it can cause confusion. It's similar to what R6 does with the classes. So once you define a class, it's hard to redefine the class, and it takes, in Bioconductor, you sort of have to do a bunch of other steps if you're modifying a class to check that anyone that is using your class has a valid class, and we'll see how to validate classes further down in the chapter. But for interactive use, I don't know how relevant this is, but usually when you're defining a class, it's in a package, and you try to design your class with some of the you try to predict how people will use your class, and if you do need to add things to your class, you try to create a new class rather than modify the old one. So in this helper section, Hadley talks about the new function, which is a low-level constructor that you can use as a developer. You should have a user-friendly helper. So that for what we use in Bioconductor, we call it the constructor function. So it's a user level function that validates all of the inputs to generate an instance of your class. So usually this helper function or this constructor function should have the same name as the class. So my class. And here we see there's a person or a plain old person function that will generate a person class instance. And then you'll want to have a thoughtfully crafted interface. So that means that you're considering all of your arguments carefully, and you've chosen some default values and useful conversions. And then add some error message that allow the user to troubleshoot any inputs that they provide. And then you finish by calling methods new. In Bioconductor, usually you take the generator function and use that instead of the new function call. So the generator function is this the value of the set class or the output of the set class function that will give you a generator function. And usually what we do is set it to dot person and then use that in your constructor function. The behavior is pretty much the same. There's some slight nuances as to why you would use it, but that's how we do it in Bioconductor. But once you have this helper or constructor function, you can provide that in your package and allow the user to just type in the values. You have appropriate defaults, right? So that's, I guess, one of the reasons why I don't really use prototypes, because I'm always creating a constructor function that has any relevant checks and defaults for those slots. So it is a little bit redundant, but it doesn't hurt to have. So if you just provide a name input, you should get an instance of the class person with Hadley and the NA that was provided as the default argument for age. So one of the good things about S4 is that you have these validators which check that your class is a valid class. And in this case, the constructor checks that the class, well, in this case, there was no nothing to catch. That name is a character type. So it will try to create a instance of person with empty cars in the name, and it will just throw an error because there is some checks in the way the class was defined, right? That the name is a character. So it hits that part of the code and tells you that it's an invalid person. Object name is class data frame, it should be character. So there's some validation going on in the background, but there are ways to add more validity checks to your class. So you'll need to create more complicated checks. You want to make it clear that the person class is a vector class and can store data for multiple people. So in our constructor function, we didn't check for the length of that or anything like that. So this would be a valid input. But what we really want is just a single value of age and a single value of the name. So we can add a validity check to make sure that those lengths match. So here you use the set validity function on the class name, and then a function that either gives you some message of what's wrong or it returns true. And here we're checking that the name of the object is the same, or if it's not the same as the age, then return this message that they should both be of the same length. So once you run this bit of code in your global environment, that will add that validity step to the person class. So whenever it's generated, when the person class is instantiated or created, it will run that part of the that validity, and you will get maybe a more useful message. Name and age must be of the same length here. So there are ways to add additional checks, not only for the slot types, but also how these different slots interact with each other, or things that can't be defined by just the type of the slot. So these are like length relationships between the two slots. So it's called so the validity method is called automatically by new. So you can still create an invalid object by modifying it. So there R gives you many ways of shooting yourself in the foot. And this is one of them. You can create a person class instance here called Alex, but you can modify the slot here directly by doing @age and setting it to 1 to 10. And that will work. But you can check if it's valid by doing valid object on the Alex object, and that will run the validity checks that you set in set validity, and it will give you the error that they must be of the same length. So it's a valid object is a good way to see that the class you've created is if or modified is valid, and that comes in handy if you are changing a class definition, say in a package. Maybe you're adding some things or redefining some slots in a class. You want to make sure that any previous instances of your class, because sometimes these classes in the wild can be serialized, and that can cause problems because someone might save a class, say in a previous version of your package, they serialize it as an RDA file or a file, RDS file, and then they come back, you modified the class definition, and now it's not working because the modifications are not compatible with the old class. So valid object will allow you to see what's wrong with the class and then create a method for updating the old class. So just when you particular use of valid object. Now let's talk about the generic and methods. And so the job of a generic is to perform method dispatch. So it's sort of like the top, the like I said, I guess the front line of the function, and it will sort of find the method appropriate for the generic call. So you use set generic, which is the function with a name for that particular function. So it depends on what you want to do with the class. So in our case, we had age. We were creating an accessor generic. And then you set the name and provide a function standard generic name of the generic. So that would be age, right? So that creates the generic, and by convention, it's lower camel case. It's also a bad practice to use the curly brace because it has some performance implications when you use that. So don't use the curly braces when defining the generic. I guess one thing is when do you define a generic? And it's a good question. I guess you would define a generic when you expect other classes to use that generic. So say maybe you have a summary generic and you create a summary generic and a summary method for your class. So if you think that someone else might need a summary method for their class or might want to use a summary method for their class, and that's a good way to a good reason for setting or creating a summary generic. If you're creating a very special or very specific a computation for your class, and you don't expect other classes to do this sort of operation, then it might be better to just create a plain function instead than a generic. So that those are some of the cases where you might want to use a plain function because you don't expect other classes to use this computation or this command. So one aspect of the set generic function is that you can define what is called the signature, and this will tell R how to dispatch using this generic. So the signature tells R that some of these arguments in the function pertain to a particular defined S4 class. In this case, we only want to tell R to dispatch based on the class of X. So if a signature argument is not supplied, then all of the arguments except the triple dots are used. So in this case, we don't want verbose. We don't want the dispatch to be dependent on verbose. We only want it to be dependent on the the class of X. So that's why we say signature X in this example. So then when you're creating a method for your class, so a generic isn't useful for by itself, right? You need a method. So you use set method to create the method, and 3 important arguments: the name of the generic that we created previously, and the name of the class, and the method itself. This doesn't look quite right, but your method signature or argument should look exactly the same as your generic argument. So you should have X triple dot and verbose equal true in your method arguments. So don't forget that. And R will know that your X is what you're dispatching on, which should be a person class object. Here we're using the short notation for that signature argument, but if you have multiple things you're dispatching on, you want to provide a named character vector for the arguments that you're dispatching on. So here it's a simple case, so you just say person because there's only one thing to dispatch on. So the other thing that we want to provide usually when you create a class, you want to have a nice printout that gives the user the information that they would want to see or that they need from the class. And the show method is already, so we need, whenever we create a method, there should be a generic somewhere that we're using. And if I'm not mistaken, the show method is part of the show generic is part of the methods package. So the only thing you need to do is to create the method, right? And you should also import the show generic, especially when you're like writing a package. So you can do get generic show to look at the arguments that should be in your method. So in this case, it's just a single argument called object. So when you create your show method, you do function object for the person, and then the implementation of the show method, which usually uses cat to print out to the console some nice formatting for your class. So you do something like name of the class, carriage return, name value, and then the value of the value in the slot, and so on. So you'll see that gives you a nice printout. So slots are an internal implementation detail, as I was mentioning earlier. So it's mainly for the developer, and the developer can change that. It's free to change that whenever. So in order to add that layer, you should provide some accessor functions. And in this case, this is a plain function, but generally you want accessor functions that are generics, right? Because that they should work on your class, and maybe and the generic should also work on descendant classes, so like the employee class. So create a generic for the accessor in this way, right? No curly braces, just standard generic name, set method name, person, and x at name to pull out or to extract the name value in that slot. So that gives you name, but I don't know if we have the employee example, but for the replacement, function, you create a generic, right? Name arrow, and then standard generic, make sure you have your X and your value, right? That's the thing that you're replacing the name with. So create the generic, create the method and the implementation as we saw earlier. But in this time, we use the valid object. So it will check to see that the value that was provided is a character value of the same length of age, right? Because we have also our validity check function. So it will check to see if it's valid, and then if that passes, then it will return the X class or the person instance. So then you can use the setter with a new name, John Smythe, and that would then access the name to get the value in that name slot. But you can try to give it the letters internal value, which corresponds to the letters of the alphabet, which is like not the same length of the age as age. So it will give you an error, right? So hopefully everyone's familiar with the letters internal object. So then we move on to method dispatch, and this gets a little bit more complicated because not only the inheritance, but also the dispatch. So there are two important features, right? Multiple inheritance. A class can have multiple parents and then multiple dispatch. So you can dispatch on multiple arguments in a method, right? So you might not only want to dispatch on X, but you might have a Y value to dispatch on. So it makes it very powerful, but hard to understand which method will get selected given a combination of inputs. So in practice, you want to keep it as simple as possible and maybe just dispatch on a single argument. And that will keep things as linear as possible in the inheritance chain. So here Hadley has this nice class graph based on emoji, and here you can see that the parent class is this blank face. Maybe I should make this a bit bigger. The parent class for all of these emoji are blank, is the blank face. You can have a smile and then you can add some sunglasses to it. But the sunglasses are also its own class. So you can see how these things are related, right? Blank face, you add a grin, then a smiley face, and then a sweat smile. So it's a good way to show inheritance here. And then for single dispatch, right, we only have one argument that we're dispatching on, but based on the inherited classes, depends on which method is defined first or available first, that the method used is the method that is first available. And so here the F, the top part, defines the scope of the diagram. So we have a generic with one argument. This means it's one argument that has a class hierarchy that is 3 levels deep, right? And then the bottom part is the method graph, which gives you all the possible methods that could be defined. So that means methods that have been defined with set method have a gray background. So in this case, the blank face has a defined method because it's has a gray background. So if you have a winky face class, or and you use the method for it, it'll look for any of those defined methods and find that there's only one and use that one. And then there are some pseudo classes that you will want to define methods for, just in case, for fallbacks usually. And that's the any pseudo class, which you can think of it as the last resort method for the chain here of inherited, the chain of methods here. So you can also define you can also use the pseudo class missing. If the argument is missing, then it will run a method for whenever that argument is missing. So it may be useful for like double dispatch when you have one argument that's available, but the other is missing. You might use it like that. Or yeah, it's not very often used, but it is possible to use that pseudo class. And then we'll talk about multiple inheritance. So it gets more complicated when the class has multiple parents, and not only do you have the blank face, but also the sunglasses class. So you can see that the graph gets a little bit more complicated. So what happens if the methods are the same distance? Imagine we define the methods for the sunglasses and the smiley face. And then we call the generic the sunglasses emoji. There's no method found for the blank face class, so that's highlighted in the red double outline. So this is called an ambiguous method, and he'll illustrate it with thick dotted borders. And when this happens in R, you get a warning, and the one that comes earlier in the alphabet will get picked. So you should always try to be explicit and define a method for the leading instance, I guess, or the class, if there is one. So when you have multiple inheritance like that, you try to define the method, the first one here with the sunglasses smiley face, to avoid that arbitrary picking of methods and avoid the ambiguity. That also note that the any method is always is there. I guess you'd have to define it yourself, like set method for class any. But the rules are, it's not very helpful to rely on this any method. You should always try to define the methods that's most closest to the class that you are working with to avoid the ambiguity. So, and here are some more diagrams here, like the blank face and the sunglasses don't have any methods defined. So if you dispatch on the sunglasses face, then it will find that method and use it. Or if it's you can sort of see what these relationships look like, right? Sometimes there is no method for like a particular class, so it'll go back into the default. So it gets really complicated. There's 6 ways to define only 2 methods for this call, but only one of them is free of problems. So he recommends using multiple inheritance with extreme care and think carefully about your method graph and plan accordingly. So yeah, so I think these are might be the only one without problems here is this bottom right one. So now we have added complication here with multiple dispatch. So if you have 2 arguments that are themselves classes, right, and they each have their inheritance chain, then you can see how these things can start to interact. And you'll have like this diagram of scenarios where methods are defined for a particular combination of those classes. So you can see that first R will look at the wink smile face for both arguments. If that's not available, then it'll look for the wink tongue out method. And then if that's not available, it'll go on and on until it reaches the 2 parent classes, the blank faces. So you can see that there are a lot of combinations here, and you might have some methods defined for either or. Like you can have for the tongue out wink and the wink methods, you could have methods defined there or here. So it produces ambiguous. It has 4 defined methods here. So the shaded ones are defined and has 2 ambiguous cases, the top and the center one here. So multiple dispatch tends to be less tricky to work with than multiple inheritance because there are usually fewer terminal class combinations. So you can define a single method and have default behavior for all inputs. So then you have multiple dispatch and multiple inheritance, which makes things even worse. So you can have the first argument can have a inheritance of 3 classes deep, but then the second argument can have a 2-level inheritance from the sunglasses and the smiley face, right? So R will go through that graph here and look for the methods that are available for each of those combinations. So you can see that it starts to get complicated quickly with only just 2 arguments that have um, different class types. So, and even more complicated when you have dispatches on classes that have multiple inheritance. So it's not a um, straightforward graph here. So you want to keep the graph linear as possible, and it's harder to predict which method gets called given a combination of inputs. So you might have to draw the diagrams to figure out what method is actually going to be called, and go back and simplify your design. And if you're using classes from other packages, you might have to work with the maintainer of that package to sort of fix things if problems arise in the chain of methods. So try to keep it as simple as possible. And the stuff that I write is usually like just a single class dispatch. And yeah, makes it easier. So let's see how we're out of time. Okay.
Yeah, I didn't
So
want to stop you, but yeah, we're running low on time.
yeah. This yeah, if I'll just note here that if you're using S4 or S3 classes, you can use the settle class to bring it into the S4 context and dispatch on it. So that's pretty much it. Yeah. So I'll stop there and should have kept track of time, but thanks everyone.
Yeah, thank you so much, Marcel. That was a really excellent presentation. I'll see everyone next week. I will be presenting on the trade-offs between these different object types, or object systems, I should say. And thank you once again to Marcel. That was really, really thorough and interesting. Thank you.
Thanks.
Okay, bye.
You.